This video will cover rounding numbers to the proper number of significant digits, significant figures. If you haven't watched the video on counting significant figures, take a minute and look at that now. When we're rounding numbers to the proper number of significant figures, we have some number. It might have come out of a calculator or some calculation, and we want to express this with the proper sig figs. We figure out, let's say in this case, there are 3. The first step is to identify the last significant digit. So 1, 2, 3. Go ahead and identify it. I prefer by underlining it. And this is very useful because it can let you keep track of sig figs through a calculation. But we've identified our last significant figure, that 8. You then look to the next digit. If the next digit is 0 to 4, you leave your last significant digit the same, and you replace these other zeros. If they're after the decimal point, you just get rid of them. If you need them as placeholders, if they're before the decimal point, you replace those digits with zeros. In this case, we don't need to keep them to mark where the decimal point would be, so this number should just be 14 point. If it's 5 to 9, we increase it. So 5 to 9, this becomes 14.9 milliliters. Let's practice some more. We're going to round each of these to 3 significant figures. First step, figure out what the last significant figure is, and you do that by counting. Start with the non-zero digit, 1, 2, 3. You look at the digit 1 to the right. If it's 0 to 4, you leave that number the same. This is 80.0 grams. Okay, leading zeros don't count. We start at the first non-zero digit, 1, 2, 3. We look to the digit 1 to the right. In this case, it's 5 or greater, so we increase that 7, and our answer is 0.0688. In scientific notation, again, we're going to keep this modifier at the end, the times 10 to the something, but our number are these first 4 digits here, 1, 2, 3. The number on the right is 5 or greater. Now, I'll caution you on 5s. In other classes, they may use different rounding rules that are a little more complex, but for 3A, 5 or greater, you increase this digit. Now, this is interesting. This one increasing means we have to carry it over, and it becomes 2.00. And then we have to remember to put that times 10 to the negative 6 on there. Okay. 1, 2, 3. In this case, it's 4 or less, and it would stay 1.99. We just get rid of that 4 times 10 to the negative 6. Don't forget to stick the units back on. On the right side, I have some interesting special cases. So this one comes up reasonably often, and calculators in Excel will drop trailing zeros. So let's say your calculator has 0.082, but you know you need 3 significant figures. In this case, 1, 2. The third significant figure is missing. I'm going to go ahead and add back in that trailing 0 to fill that third spot, 0.0820 grams. So watch out for this. Remember, your calculator will drop it, but there are zeros after this. In this case, that next 0 is significant, 0.0820. The second case comes up very rarely, but in this case, 1, 2, 3. As I'm rounding to 3 significant figures, I'm saying I have uncertainty in this position. 1 to the right means I increase this number, and it becomes 10.00. And this may seem counterintuitive because that doesn't have 3 significant figures. That's 4. 1, 2, 3, 4. Okay. But when I rounded to 3 sig figs, that is my last uncertain digit. That should be the uncertain digit in my answer. Okay, double check with your instructor if you're not in my course. They may have a different view of how you should handle this rare special case. And this next one comes up pretty often as well. 1, 2, 3. Now, the 4 means I leave that number the same, but 820 is not the same as 820,000. I need to replace these digits that I'm getting rid of with placeholder zeros because I need this to be approximately the same number. We didn't replace them with zeros when they were following a decimal point because we didn't need them there to mark that this was 80. Here, this is about 820,000. We need these trailing zeros here to mark it, to essentially keep it as 820,000 and not reduce it to 820. And this is why when you don't have a decimal point, trailing zeros aren't significant, because you can't be sure they're written to describe the precision of the measurement instead of to just keep the decimal point in the right place. So 820,000. Replace these digits you're dropping with zeros if they're before the decimal point. Okay, let's go ahead and check your understanding. Go ahead and pause the video and answer this question for me. Okay, start counting at the non-zero digits. 1, 2, 3. That is the last significant figure. That was the first step. Identify it. Look one digit to the right. In this case, it's 0 to 4, so this number stays the same, 0.0106 milliliters. And in my answers, that's C.